Math 1314, Tyler Junior College. Section 3.3, Dividing Polynomials, Remainder and Factor Theorems. Synthetic division. In a previous video, I mentioned that there were two types of polynomial division, long division and synthetic division. Long division always works, and it is always long, hence the name. But for some division problems, not all, for some division problems, there is a technique that is faster and takes up a lot less space, and it's called synthetic division. But when does it work? Synthetic division works only if the divisor is a monic linear binomial. Let me translate. A binomial means that it has two terms. You should know this. Algebraically, the word linear means that the degree is 1, so the highest power is just x to the first. Now the word monic, the adjective monic, is actually an adjective that a lot of math professors do not know. They should. Ask yours. What does monic mean? The root word of monic is mono. Well, not the root word, but the root of it is mono, meaning 1. Monic, in reference to polynomials, means the leading coefficient is 1. So there are two terms, the highest power is x and the leading coefficient is 1. In other words, it has to start with just x. I know that's a fancy way of saying it has to start with x. There's only two versions of monic linear binomials. A purist will argue there's only one version. But the two versions are x minus a number, which we'll call x minus c, or x plus a number, which we'll call x plus c. So synthetic division is very limited in when you can use it. Your divisor must be x minus a number or x plus a number. Now, in case there's somebody trying to rock the boat, yes, you can adapt synthetic division, not just for non-monic linear binomials, meaning there's a number in front of the x, but there's actually a bizarre way that you can adapt synthetic division to any polynomial division problem, but it becomes so cumbersome that it defeats the purpose of being quicker and faster than long division. So we're only going to focus on synthetic division for when it was meant to be used if the divisor is x minus a number or x plus a number, such as in this example. We're going to divide x to the fourth minus 3x to the third plus 2x squared plus 7x minus 19 by x minus 2. Notice that the divisor is monic, leading coefficient is 1, linear, degree is 1, binomial, two terms. Now, synthetic division takes a little time to explain up front, but once you understand the flow of it, you'll see why it is much more efficient than long division. Synthetic division has three parts. The first part is the setup. Now the setup has two parts to it, so we'll say A and B. Before I write what they are, let me kind of describe how it's going to look when we set it up. Synthetic division is going to have, when it's all said and done, 3 rows of numbers. These red arrows I'm drawing are not part of synthetic division. I'm just pointing to where the 3 rows will be. There will be 2 rows of numbers separated by a horizontal line, or separated from a third row of numbers by a horizontal line. So a row of numbers, horizontal line, one final row of numbers. To the left of the top row, there will be an extra number. Most books will put what looks like half of a square or a backwards capital L. I personally like to put the whole box there. So to the left of the top row of numbers, there will be a box, and inside that box, there will be another number. Here's the setup. The top row equals the coefficients of the dividend. Translation. Take the polynomial you are dividing into and write the coefficients. Essentially, you're removing all the x's. The coefficient of x to the fourth is 1. The coefficient of x to the third is -3. You want to keep them spaced out a little bit. The coefficient of x squared is 2, positive 2 to be more specific. The coefficient of x is 7, and the constant term is negative 19, excuse me. That's all the top row is, the coefficients of the dividend, excuse me. For the divisor, that helps us determine what I call the box number, the number that's going to go in the box. The box number is the 0 of the divisor. Recall that a 0 is a value that makes a function equal to 0. So the box number is whatever number you would put here that would cause this to equal 0. More descriptively, it's the opposite of this constant term. Since this constant term is negative 2, the box number is going to be positive 2. 2 is the number that would make this expression equal to 0. Now, why do we change the sign? Because in long division, every time we subtract, we have to change every single sign every single time. Changing this sign once takes care of all of that in one move. That's why we changed the sign. But that's all there is to the setup. You essentially remove the x's, but you replace, in the box, you put the opposite of the number in the divisor. Basically, the divisor 0. That's all there is to the setup. Now, the second part of synthetic division is the work. When we do the work, we now need to think in terms of columns. With the exception of the box number, every number in the top row represents a column. So this synthetic division problem will have 5 columns, since there are 5 numbers in the top row. You start with the leftmost column. In the first column, all you do is bring down the number. Bring down the number. You bring it all the way down to the bottom row. So bring the 1 down. That's pretty easy. Nothing happens. Just bring the number down. But here's where the actual work begins. Your second step, you multiply diagonally by the box number. By the box number. The box number is a multiplier. If you want to put a times in front of it to remind you it's a multiplier, that's okay. But when I say multiply diagonally, that means we're going to go to the next column but up 1 row. So we're going to go this direction. You don't have to draw the arrow, I'm just pointing where I'm going. And when you go diagonally, you multiply by what's in the box. 1 times 2 is 2. That was easy. Multiply diagonally by the box number. After you've multiplied, your next step is to add the next column. Because now in the next column, we have 2 numbers to add. We have a negative 3 and we have a 2. Negative 3 plus 2 is negative 1. Then you just repeat B and C. You repeat the multiply and add until you've added the final column. Until you've added the final column. So all you're doing is adding and multiplying. You just got to remember when to do what. After you add, you multiply diagonally by the box number. Negative 1 times 2 is negative 2. And then you add this column. 2 and negative 2 is 0. Then multiply diagonally by the box number. 0 times 2 is 0. Add the next column. 7 plus 0 is 7. Multiply diagonally by the box number. 7 times 2 is 14. And then finally add the last column. Negative 19 and 14 is negative 15. That's all the work there is. Bring down the first number and then multiply, add, multiply, add, multiply, add. It's really quick, especially if the numbers don't get out of control. And by the way, if you forget when to multiply and when to add, there is a visual gimmick. I take full credit for this. I've never seen it anywhere else. I made it up on my own. When you're going diagonally, that's half of the times sign. But it gets better. When you're adding down the column, that's half of a plus sign. So the direction you're going is drawing out half of what you should be doing. When I go diagonally, I should be multiplying. When I go vertically, I should be adding. Multiply, add, all the way until the end. And that's all the work there is. The third part of synthetic division is the answer. Because after all, we're still doing a polynomial division problem. I'm expecting a polynomial answer. You start synthetic division by basically taking out all the x's. So you end by putting them back in. The answer comes from the bottom row. And the answer has two parts. The bottom row represents the coefficients of the quotient. But the degree of the quotient, is one less than the degree of the dividend. Is one less than the degree of the dividend. This is easier to do than it is to put into words. Translation, put the x's back in, but lower the power by 1. When I started the division problem, my dividend started with x to the 4th. When I ended it, my quotient's going to start with 1 power lower, x to the 3rd. So this 1 represents 1x to the 3rd. And then each following number represents the coefficient of the next lower power. So this -1 represents -1x squared. The 0 represents 0x. And because we need a sign, we'll put a plus, but at 0 it doesn't matter. And then this 7 represents the constant term plus 7. So all the x's go back in. Now what should happen is you should run out of x's at the second to last number. There should be one more number left. That number is the remainder. Last number equals the remainder. And we're going to do the same thing with the remainder that we did before. We're going to take the remainder, which is -15, put it on top of the divisor, which was x minus 2, and add it on to the rest of the answer. And that's it. Now this answer should be cleaned up a little bit. I think most online homework platforms would accept this, but we shouldn't write things that we don't need to, such as the 1 in front of the x cubed, or the 1 in front of the minus x squared, or this term because there are no x's here, so we can just drop that, plus 7. And there's even one more thing we could do, although it's not really necessary. If your remainder is negative, you can factor the negative out and change this to a minus. So we could just say -15 over x minus 2. In my opinion, and this is the cleanest looking answer, although the one above it is perfectly correct. In the next video, we'll do a few more synthetic division examples so I can illustrate that it really is a quick and efficient technique.